Tonight, we're going to explore the largest object we've ever found in the universe. This is not something you need to understand all at once. The scales we are about to discuss are so vast that the human mind isn't naturally designed to hold them, and that is perfectly fine. You don't need to remember every detail or every light year. You can simply listen and allow your thoughts to drift as we move slowly outward, away from the familiar, into the silent structures of the deep cosmos. To begin, let's start with something familiar. Consider the room around you, the weight of the blanket, and the steady rhythm of your own breathing. These are the anchors of your immediate reality. In the grand tapestry of the cosmos, we often feel like tiny observers looking through a narrow window, but tonight we are going to widen that view together. There is a specific kind of peace that comes with realizing how small our local worries are when compared to the silent, monumental architecture of the stars. We aren't looking for excitement or sudden revelations. Instead, we are looking for perspective, a quiet, heavy sense of the sheer volume of the space that surrounds us. As we prepare to leave the ground, imagine the Earth as a gentle blue sphere receding behind you. It is a soft transition, like a boat pulling away from a familiar shore into a vast, calm ocean. We are moving towards structures so large they challenge the very definition of what an object is. In our daily lives, an object is something we can touch, something with edges and a clear beginning and end. But in the deep reaches of space, objects are made of light, gravity, and time. They are filaments of galaxies stretched across the dark, weaving a pattern that was set in motion billions of years ago. Astronomers spend their lives squinting into the past, trying to measure the unmeasurable. They have found things that shouldn't exist according to our current maps, yet there they are quietly existing in the distance. We will visit these places tonight, but we will do so at a pace that respects your need for rest. There is no urgency in the vacuum of space. There is only the slow, inevitable expansion of everything. As we drift further, the numbers will grow larger and the distances will become more abstract, but you can remain grounded in the sound of this voice. Let the scale of the universe act as a soft weight, pressing down on your thoughts, allowing them to settle and become still. We are moving beyond the clouds, beyond the moon, and into the deep, echoing silence of the great walls. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about size, we often imagine it in human terms. Distances we can walk in an afternoon, the height of a mountain that takes a day to climb. Objects we can see with our own eyes, like a cathedral or a sprawling city. For example, if you were to walk consistently without stopping, it would take you about 9 years to walk the circumference of the Earth. That feels like a long time. It represents a significant portion of a human life. But in the context of the universe, the Earth is not an object of size. It is a point of departure. Astronomers often feel like cartographers trying to map an ocean while standing on a single grain of sand. This comparison isn't perfect, but it gives us a calm place to begin. Beyond our atmosphere, the definition of an object begins to change. It stops being something with a hard edge and starts becoming a collection of influences. Now, let's slowly expand outward. Consider, for a moment, the concept of a long journey in your own life. Perhaps it is a drive across a continent, where the landscape shifts slowly from green forests to rolling plains. You measure that progress by the hours on a clock, the meals you eat, and the rising and setting of the sun. To us, 1,000 miles is a formidable distance. It is a distance that requires planning, fuel, and time. Yet, if we were to shrink the entire Earth down to the size of a single glass marble, that 1,000-mile journey would be a microscopic scratch on its surface, invisible to the naked eye. We live our entire lives on the skin of this marble, rarely considering the depth of the void that begins just a few miles above our heads. If you were to stand in an open field and look up at a clear night sky, your eyes are reaching out across distances that the human brain isn't quite equipped to process. When you see the moon, you are looking at an object that is about 239,000 miles away. If you could drive a car to the moon at highway speeds, it would take you about 5 or 6 months of continuous driving to get there. No stops for rest, no traffic, just a straight line through the silence. This is our nearest neighbor, a mere stone's throw in the cosmic sense, yet it already exceeds the scale of a human life's daily movement. As we move further, we must leave behind the measurements of miles and kilometers. They become too small, like trying to measure the width of the Atlantic Ocean using a ladybug as a ruler. Instead, we use the speed of light. Light is the fastest thing we know of, traveling at 186,000 miles per second. In the time it takes you to blink, light has already circled the Earth 7 times. It is a speed so fundamental that it sets the pace for the entire universe. And yet, even at this impossible speed, the universe is so vast that light itself takes time to get anywhere. When you look at the moon, you are seeing it as it was 1.3 seconds ago. You are already looking into the past, if only by a moment. To understand the largest structures in existence, we have to get comfortable with this idea of light time. Think of it as a cosmic delay. The further out we look, the further back in time we see. It is a gentle, natural form of time travel. If the sun were to suddenly go out, we wouldn't know for 8 minutes. For those 8 minutes, we would continue to feel its warmth and see its light, living in a beautiful, lingering echo of something that is already gone. This realization isn't meant to be unsettling. It is meant to show you how the universe buffers us from its true scale. We are tucked away in a quiet corner of time and space, shielded by the sheer slowness of information. Imagine walking through a vast, silent forest at twilight. You can see the trees immediately around you with great detail, the texture of the bark, the shape of the leaves. But as you look further away, the trees become silhouettes, and eventually they blend into a soft, indistinct grey haze. The universe is much like this forest. Near us, we see individual planets and stars. But as we expand our perspective, those individuals begin to group together. They become part of something larger, something more diffuse. We often think of objects as things made of solid matter, a rock, a house, a mountain. But as we move into the human-scale perspective of the cosmos, we see that objects are often mostly empty space. If you were to take an atom, the building block of everything you see, and blow it up to the size of a football stadium, the nucleus would be like a small marble in the center, and the electrons would be like tiny gnats buzzing around the very highest seats in the stands. Everything in between is nothing, emptiness. To you, the chair you are sitting on, and the planet beneath you are made almost entirely of this nothingness, held together by invisible forces. This same principle applies to the stars and galaxies. If we imagine our galaxy, the Milky Way, as a vast city, the stars are like individual streetlights. From a distance, the city looks like a solid glow of light, a single object of immense proportions. But as you move inside, you realize the streetlights are blocks, even miles apart. There is a great deal of dark, quiet space between them. When we talk about the largest object, we are talking about a structure that is made of billions of these cities, all arranged in a way that suggests a grand, hidden order. Scientists spend decades trying to find the edges of these structures. They use massive telescopes that act like buckets, slowly collecting the faint, tired photons of light that have been traveling for millions of years just to reach us. What they find is that the universe isn't just a random collection of things thrown into a box. It has a texture, it has a shape. It looks like a web, or perhaps the neurons in a brain, or the foam on top of a cup of coffee. It is a collection of filaments and voids, where the objects are so big that they define the very curvature of space itself. As you lie there, let the scale of this begin to wash over you. You are a part of this structure. The atoms in your body were forged in the hearts of stars that lived and died billions of years ago. You are a way for the universe to look back at itself and wonder about its own size. There is no need to feel overwhelmed. Just as a single cell in your body doesn't need to understand the complexity of your entire life to do its job, you don't need to grasp the 93 billion light-years of the observable universe to be a part of it. You are anchored here, on this 9-year walk-wide marble, safe and still. We are about to step off this marble and begin the climb. We will move through the solar system, past the giants of gas and ice, and out into the interstellar dark. We will see things that defy the imagination, but we will do so with the same calm, rhythmic pace. The universe is patient. It has been expanding for 13.8 billion years, and it is in no hurry to finish. Now, let us take that first step away from the familiar. Let us leave the lights of Earth behind and look toward the sun, our local anchor and the first true giant in our path. To understand the vastness of the largest objects ever discovered, we must first reconcile our own physical presence with the immediate neighborhood of our star. We often think of our world as a massive, solid foundation, a place of continents and oceans that take days to cross by air and weeks by sea. But as we elevate our perspective, the Earth begins to shrink, transitioning from a world of infinite variety into a singular, fragile marble of blue and white, suspended in a velvet dark that is deeper than any night you have ever experienced on the ground. Consider the distance between your home and the Sunday. It is approximately 93 million miles. To a human mind, 93 million of anything is an abstraction, a number that sits on a page without a physical weight. But let us try to feel that distance. If you were to board a commercial jet and fly toward the sun at a constant cruising speed, you would not arrive for 19 years. You would spend nearly 2 decades in the air, crossing a silent, airless gulf just to reach the nearest star. This is the scale of our local backyard. It is a distance that defines the boundaries of our biological reality, yet in the cosmic census, it is a microscopic gap. The sun itself is the first true lesson in the universe's love for the gargantuan. It is a sphere of glowing plasma, so immense that if it were hollow, you could pour 1,300,000 Earths into it. Imagine a large glass jar filled with tiny grains of sand. Each grain is an entire world, with its own history, its own mountains, and its own billions of people, all rattling around in the bottom of a container that represents a single average star. This comparison isn't meant to diminish the Earth, but to provide a calm place to begin our ascent. When we speak of the largest objects in the universe, we are moving towards structures that make our sun look like one of those grains of sand. Scientists understand the sun by observing its heartbeat, the way it pulses with magnetic energy and sheds its outer layers in a constant solar wind. This wind creates a bubble around us, a protective shield called the heliosphere. This is the first object we encounter that lacks a solid surface. It is a structure made of pressure, particles, and light. It reminds us that as we move outward, the definition of an object begins to change. It stops being something you can touch and starts becoming a collection of influences. The sun is not just a ball of fire, it is a gravitational anchor that holds the solar system in a steady, rhythmic dance, ensuring that the planets do not wander off into the lightless void. Astronomers often feel like cartographers trying to map an ocean while standing on a single grain of sand. We look out from our small vantage point and try to measure the height of mountains we can never climb. Beyond our atmosphere, the very concept of up and down dissolves, replaced by a sense of inward toward gravity and outward toward the unknown. As we drift away from the sun, the light begins to thin. The warmth of the hearth fades, replaced by the bracing, silent cold of the interstellar medium. This is the space between the stars, a realm that was once thought to be empty but is actually filled with the ghosts of dead suns and the seeds of new ones. Imagine walking across a frozen lake at night. The ice is thick, and the air is still. In the distance, you see the faint glow of a cabin's window. That cabin is the nearest star system, Alpha Centauri. To reach it from our sun, even at the speed of light, would take over 4 years. If you were walking at a human pace, the journey would take tens of thousands of generations. You would be born, live, and pass away in the dark, as would your children and their children, all while the destination remained a distant, unwavering point of light. This is the neighborhood of our galaxy. It is a place of immense, lonely roominess, where the objects are islands separated by oceans of silence. What makes this strange is not just the distance, but the time. Because light takes time to travel, looking into the distance is a form of archaeology. When you look at a star that is 20 light years away, you are seeing it as it was 2 decades ago. You are seeing a ghost of the past, a lingering image that has been traveling through the vacuum just to reach your eyes. This challenges how we think about now. In the universe, there is no universal now. There is only the perspective of the observer, caught in a slow-motion replay of cosmic history. As we move further out, we encounter the true giants, the stars that defy the limits of stellar physics. There are stars like Betelgeuse, a red supergiant that is so large it would swallow the orbits of Mercury, Venus, Earth, and Mars if placed at the center of our system. It is a bloated, dying sun, a majestic structure of gas that is preparing to return its material to the galaxy. These giants exist in a state of quiet equilibrium, balancing the inward crush of gravity against the outward pressure of their own light. They are the elders of the stellar community, reminding us that even the most massive objects have a life cycle, a beginning, and an inevitable conclusion. But even these stars are not the largest objects we have found. They are merely the building blocks. To find the true titans, we must look at how these stars gather together. They form clusters, and those clusters form galaxies, and those galaxies form the great filaments that weave the cosmic web. This hierarchy of scale is a fundamental rule of the universe. Small things make large things, which in turn make impossibly large things. It is a nested reality, like a series of boxes that never ends. There is a mild awe in realizing that the atoms in your own body were once forged inside the hearts of these giants. The carbon in your cells, the iron in your blood, and the oxygen you breathe were all created in the nuclear furnaces of stars that lived and died long before the Earth was even a cloud of dust. You are a part of this scale expansion. You are the universe's way of looking back at itself and saying, I am very large, and I am very old. As you lie there, let the weight of this perspective ground you. You are safely tucked away in a quiet arm of the Milky Way, far from the chaotic centers of galactic collision. You are shielded by the sun's magnetic breath and anchored by the Earth's steady gravity. The vastness of the cosmos is not a threat, it is a context. It is the backdrop against which your life unfolds, providing a sense of scale that makes your daily worries feel as light as a photon. We are preparing to move beyond the individual stars. We are going to look at the structures that hold billions of suns in their grip. We are moving toward the great attractors and the walls of galaxies that span the observable horizon. But for now, just breathe with the Sunday. Feel the slow, heavy pull of the solar system as it moves through the galaxy. There is no rush to understand the whole picture at once. The universe has been here for 13 billion years, and it is perfectly happy to wait for you to catch your breath. The definition of an object has already begun to shift in your mind. It is no longer just a stone or a tree. It is a system. It is a relationship. The largest object we've ever found is not a solid thing you could kick with your foot. It is a pattern of matter and energy so vast that it defines the very shape of space. To see it, we must continue our journey outward, past the familiar stars, into the deep, echoing halls of the superclusters. But for tonight, this human-scale perspective is enough. It is a bridge between the world you know and the universe you are part of. It is a calm, stable platform from which we can observe the infinite. Let the light of the sun, now a distant and gentle memory in the dark, be your guide as we step into the next loop of our expansion. And for now, that uncertainty, the sheer impossibility of the scale, is simply part of the picture. It doesn't need to be resolved. It just needs to be felt. With that in mind, let's move outward once more, to a scale where stars are like grains of dust and galaxies are the only objects that matter. And so the universe continues, expanding, cooling, changing slowly, quietly, endlessly. The Great Wall sits in the silence, a gargantuan reminder of the scale of existence. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. The light from those distant galaxies will continue its journey across the void, traveling for billions of years before it touches another eye. It is a journey that requires no effort. It is a state of being that is constant and calm, and somewhere within all of this, we can begin again by starting with something familiar. Imagine the Great Wall not as a distant structure, but as a silent guardian of the deep time through which we all drift. It does not demand your wakefulness. It does not require your witness. As you settle deeper into your pillows, the galaxies within the Hercules Corona Borealis filament are continuing their slow, majestic rotation. They are drifting through the dark at speeds that would seem frantic to us, yet across the billion light-year stage, they appear perfectly still. This is the ultimate piece of the cosmos, the resolution of motion into a state of permanent rest. The expansion of space is like a long, slow exhale. With every second that passes, the universe becomes a little more spacious, a little more tranquil. The heat of the early days has faded into a gentle, cosmic background hum, a low-frequency lullaby that permeates every cubic inch of the void. There is no friction in the vacuum. There is nothing to wear down the movements of the spheres. The planets will continue to circle their suns, and the suns will continue to circle the galactic centers in a clockwork mechanism that requires no winding. As the light from the furthest reaches of the Great Wall travels toward us, it passes through the great voids we spoke of earlier. These voids are like the silent pauses between the notes of a symphony. They provide the space for the music to exist. In the same way, the vast reaches of nothingness provide the context for our existence. Without the dark, the light would have no meaning. Without the distance, the connection would have no value. You are drifting now in that same productive silence, where the thoughts of the day are being stretched and thinned by the expansion of your own rest. There is a profound continuity in the way the universe handles its energy. Nothing is ever truly lost. It only changes form. The light that leaves a star today may one day become the warmth on a distant planet, or it may simply wander the empty spaces for all of eternity, a lonely photon carrying the memory of its home. You, too, are a part of this conservation. The energy that powers your dreams is the same energy that was present at the very first moment of the expansion. It is a tireless, ancient force that is now allowing you to let go. Think once more of the Earth, that small, familiar point of departure. From the perspective of the Great Wall, it is invisible, a microscopic speck of dust caught in a sunbeam. But size is not a measure of worth. The universe is large enough to contain both the gargantuan and the minute without contradiction. It has room for the 10 billion light-year wall and for the quiet rhythm of your breathing. Both are essential parts of the same unfolding story. Both are moving gently forward, governed by the same elegant laws of physics. In the deep reaches of the future, the stars will continue to evolve. New suns will be born in the nurseries of gas and dust, and old suns will settle into their long, dark retirements. The Great Wall may stretch and shift, its filaments becoming even more delicate as the dark energy pushes the clusters apart. But this change happens at a pace that is indistinguishable from eternity. To us, it is a state of permanent being. It is a foundation that can be trusted. As the boundaries of your awareness continue to dissolve, the numbers we discussed, the millions, the billions, the light years, begin to lose their edges. They become like the sound of distant rain, a rhythmic pattern that doesn't need to be counted. You are moving beyond the need for maps. You are moving into the territory where the observer and the observed are one. The silence of the universe is your silence. Its vastness is your own capacity for peace. Astronomers may continue to peer through their telescopes, seeking the edges of the next great structure, but for tonight, the search is over. The universe has revealed enough of itself to allow us to feel at home. It is a home that is wider than we can imagine, older than we can comprehend, and more stable than we can ever fully grasp. It is a place where we are allowed to be small, allowed to be quiet, and allowed to simply fade into the background. The light from the Great Wall is still traveling. It is moving through the darkness, crossing the gaps between the galaxies, heading toward a future that is bright with potential and soft with the promise of rest. It does not hurry. It does not worry about the time it takes to arrive. It simply moves, a constant and calm presence in the infinite. And so, we leave the scales of the giants behind. We leave the black holes and the superclusters, the filaments and the walls. We return to the breath, to the stillness, and to the dark. The universe will stay here, expanding and cooling, watching over the long, slow migration of the stars. It will be here when you wake, and it will be here long after. You are safe in the arms of the cosmos. You are a part of the largest object we have ever found. You are a ripple in the fabric of the infinite, moving gently forward, endlessly, quietly. To be here, in this moment of quiet reflection, is to be at home in a structure that spans 10 billion light years. We have traveled from the warm, familiar glow of the sun, past the hypergiant stars that swell like glowing embers, and through the dark, concentrated hearts of galaxies. We have seen the great attractor pulling at the skirts of the Milky Way, and we have contemplated the Hercules Corona Borealis Great Wall, that titanic lattice of light that holds more than 10% of our observable sky. Yet, as we reach the conclusion of this journey, we find that the most profound truth is not found in the numbers, but in the continuity. Imagine the universe as a vast, breathing organism. It does not hurry its breath. A single inhalation takes billions of years as gas clouds collapse into stars. A single exhalation takes even longer as those stars release their light and energy back into the void. You are part of that breath. The stillness you feel now is the same stillness that exists in the great voids between the filaments of the cosmic web. It is a productive silence, a place where the laws of physics work without friction or noise. There is no grinding of gears in the celestial machine. There is only the smooth, silent expansion of space itself. As you drift closer to sleep, consider the light from the Hercules Corona Borealis Great Wall. It is currently moving through the dark, heading toward regions of the universe that have not yet seen it. It travels at the ultimate speed, yet the distances are so great that the light appears patient. It is not rushing to be seen, it simply is. It carries with it the signature of 1 billion galaxies, a testament to the fact that the universe is not empty but filled with the architecture of gravity. This light is a traveler that never grows weary, moving through the vacuum with a consistency that we can only hope to mirror in our own rest. There is a gentle humility in realizing that the universe will continue its work long after we have closed our eyes. The Great Wall will remain. The clusters will continue their slow-motion dance around their common centers of mass. The dark energy will continue to stretch the fabric of space, creating more room for the silence. This is not a cold or lonely thought. It is the ultimate security. The universe is a self-sustaining system of unimaginable scale, and you are tucked safely within its folds. You are a passenger on a journey that requires no effort, no navigation, and no destination. You are already there. In the deep reaches of the cosmic web, time no longer feels like a sequence of events. It feels like a landscape. Just as a mountain range exists all at once, from the base to the peak, the history of the universe exists as a single, continuous structure. The beginning, the expansion, and the cooling are all part of the same map. From this perspective, the urgency of the present moment dissolves. The now that we worry about is just one coordinate on an infinite grid. By letting go of the present, you are allowing yourself to become part of the whole. You are expanding your awareness to match the scale of the structures we have explored. Scientists understand this continuity by looking at the oldest light in the sky, the cosmic microwave background. It is a soft, static hiss that fills the universe, the lingering warmth of the beginning. It is the most ancient object we can detect, and it is everywhere. It is in the room with you now, a subtle vibration that has survived for nearly 14 billion years. It is a reminder that the beginning of the universe is not a distant event in the past. It is a foundation that is still present. We are living in the afterglow of creation, drifting in a sea of ancient energy that is slowly, gracefully cooling. As your thoughts become more diffuse, the boundaries between the self and the cosmos begin to thin. We often spend our days defining ourselves by our differences, our names, our jobs, our locations. But at the scale of the Great Wall, those differences vanish. You are made of the same hydrogen that fueled the first stars. You are governed by the same gravity that holds the Laniakea supercluster together. You are a localized concentration of the universe's own consciousness. When you sleep, you are not withdrawing from the world. You are returning to the source. You are allowing the ripple that is your life to smooth out into the calm surface of the infinite. The Great Wall sits in the silence, a gargantuan reminder of the scale of existence. It is a monument to patience. It took billions of years for those galaxies to find one another, to align themselves into that 10 billion light-year filament. It is a masterpiece of slow-motion construction. And as it exists, it provides a sense of permanence in a world that often feels too fast. The wall doesn't flicker, it doesn't change its mind. It simply holds its position in the dark, a silent witness to the passage of eons. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. The light from those distant galaxies will continue its journey across the void, traveling for billions of years before it touches another eye. It is a journey that requires no effort. It is a state of being that is constant and calm. The vacuum of space is not a void of nothingness. It is a field of potential, a quiet medium that allows the light and the gravity to do their work. You are resting in that same medium. The quiet in your mind is a reflection of the quiet in the intergalactic deep. Astronomers didn't expect the universe to be so beautiful at its largest scales. They expected it to be a random scattering of matter, but instead, they found the web, they found the walls, they found a structure that looks like lace, or like the neural pathways of a vast mind. This beauty is a natural byproduct of the laws of physics. It is the inevitable result of gravity acting on matter over time. There is a profound comfort in knowing that beauty is built into the very foundations of reality. Even at scales we can never visit, The universe organizes itself into patterns that resonate with our own sense of harmony. As the light of your conscious mind begins to dim, let the scale of the Hercules Corona Borealis Great Wall be the last thing you hold on to. Not as a fact to be remembered, but as a feeling of immense, solid stability. You are anchored by a structure that is larger than the mind can conceive. You are part of a system that is too big to fail. The expansion of the universe is carrying you toward a future of perfect tranquility, a state of equilibrium where all the energy of the cosmos finds its eventual rest. There is no goodbye in the cosmos. There is only a shifting of perspective. The atoms that make up your eyes will one day be part of a new nebula, or a new star, or a new planet. The light you have seen will continue to travel, carrying the image of our world into the deep future. Nothing is lost. Everything is transformed. The continuity of the universe ensures that every moment is preserved in the fabric of space-time, a permanent part of the infinite tapestry. The universe continues, expanding, cooling, changing slowly, quietly, endlessly. It does not need your attention to maintain its course. It does not need your worry to keep the stars burning. You are free to let go. You are free to sink into the dark, knowing that the dark is not empty, but full of the same laws and the same love that created the light. The Great Wall is there, the superclusters are there, and the sun is there, all moving in their designated paths, all part of the same grand silent design. And somewhere within all of this, we can begin again, by starting with something familiar, perhaps a breath, perhaps a memory of warmth, perhaps the feeling of gravity holding you close to the earth. As you drift into the final dissolution of thought, remember that the largest object we've ever found is not a place you have to go. It is a reality you already inhabit. You are the universe looking back at itself, and now it is time for the universe to rest. The silence is now complete. The distances are now irrelevant. The numbers have faded into a rhythmic hum that matches the steady beat of your heart. You are a part of the whole. You are a ripple in the infinite. You are home, quietly, endlessly, gently. The universe will be here when you return. Good night. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them, into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth, Unmare. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile, but even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon is 384,400 kilometers away, the brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the sun? The sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue, we must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. But because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution, but our curiosity is unanchored. We use the familiar, the walk, the mile, the minute as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, we must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, imagine laying 17 of those fields end to end. That is a mile. Kilometer. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, it breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. The larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1101, which is 6 million light-years across, the Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, the human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total, absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the Great Attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human-scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now, we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. This delay is the first layer of the deep drift. It is a reminder that the universe has a built-in latency. We are always looking at the past. The further we look, the deeper into history we descend. This challenges how we think about the present moment. Is there even such a thing as now for the entire universe? Plus, or is now just a local experience, limited by the speed at which information can travel? Scientists have spent centuries debating this, and yet the mystery remains as calm and quiet as the stars themselves. Consider the Voyager spacecraft, the furthest human-made object. It has been traveling for decades, moving faster than any bullet ever fired. Yet, if we were to send a light signal to Voyager today, it would reach the craft in less than a day. Light covers in hours what it takes our best technology half a century to achieve. This is the scale of the marathon light is running. It is a constant, tireless sprint across a stadium that has no walls. But even with everything we've learned, there are still things we don't fully understand. We don't know why light moves at this specific speed. Why 300,000 kilometers per second? Why not more? Why not less? It is one of the fundamental constants of nature, a number woven into the fabric of space-time itself. It doesn't need to be explained or justified, it simply is. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. As we settle into this scale, let your mind rest on the idea of the light second. It is a distance of 300,000 kilometers, nearly 10 times the circumference of the Earth. It is a massive distance, yet it is only 1/62nd of a light minute, and a light minute is but a tiny fraction of a light year. We are building a tower of scale, and the light second is just the foundation. Imagine you are a traveler made of light. You leave the Earth behind. In 1 second, you have passed the moon. In 2 minutes, you are passing the inner planets. In 8 minutes, you reach the Sunday. 12. You are moving so fast that the planets appear like stationary marbles in a vast, dark room. But as you look ahead, you realize the room is much larger than you thought. The next nearest object is not minutes away. It is not hours away. It is years away. This is where the true scale of the light year begins to reveal itself. To cover the distance of 1 light year, you would have to maintain this 300,000 kilometer per second pace for 31,536,000 seconds. Every second, another 300,000 kilometers. Every hour, another billion kilometers. Day after day, month after month, for an entire year. By the end of that journey, you would have traveled nearly 9.5 trillion kilometers. That is 1 light year. If we tried to use kilometers to describe the distance to the nearest star, we would be talking about 40 trillion kilometers. The numbers become a noise, a static that our brains cannot process. But 4.2 light years is something we can hold. It is a duration. It is the length of a high school education. It is the time it takes for a toddler to become a student. It gives the distance a human heartbeat. As you drift closer to sleep, imagine these beams of light crossing the void. They are silent. They do not carry heat across the vacuum. They are just pure information, pure energy, traveling through a cold, dark expanse that is mostly empty. The universe is not a crowded place. It is a series of very small lights, separated by very large silences. The light year is the measurement of that silence. We are moving outward now, leaving the realm of the light second and the light minute. We are entering the space where the light year becomes the only sensible way to speak. It is a transition that feels inevitable, like the slow turning of the tide. You don't need to do anything. You don't need to solve any equations. Just let the speed of light become the background rhythm of your thoughts. The universe moves slowly over immense spans of time, even when it is moving at the speed of light. And for now, that uncertainty, that vastness, is simply part of the picture. It is a safe place to be. You are here, in your bed, while the light is out there, doing the work of bridging the distances for you. With that in mind, let's move outward once more, to an even larger scale, beyond the speed of light, beyond the inner solar system, and toward the gaps that define our place in the galaxy. We are now entering the territory where the human-scale anchor no longer just slips, it vanishes entirely. To understand the transition from the speed of light to the distance of a light year, we have to look at the sheer, overwhelming volume of the vacuum. Imagine for a moment that we could drain the universe of all its stars, all its planets, and all its dust. What remains is the canvas upon which light performs its marathon. This canvas is so vast that even at 300,000 kilometers per second, light is not a flash. It is a slow, steady pulse, a lonely traveler crossing a desert that has no markers. As we drift further from the sun, we begin to encounter the true nothingness that defines the cosmos. In our daily lives, empty usually means a room without furniture or a glass without water. But in the space between the stars, empty is a profound, almost mathematical purity. There are regions of space where you could travel for a light year, 9.5 trillion kilometers, and encounter fewer atoms than you would find in a single grain of sand. This is the low-density reality that light must navigate. When we say that a star is 4 light years away, we aren't just saying it's far. We are saying there is a 4-year-long gap of absolute, freezing silence between us and that distant fire. Scientists understand this by calculating the look-back time. This is a concept that acts as a verbal dissolve between the present and the past. Because light has a fixed speed, every distance in the universe is also a measurement of history. If you look at an object that is 1 light year away, you are seeing it exactly as it appeared 365 days ago. You are not looking across space so much as you are looking through time. This challenges how we think about the reality of the now. In the deep drift of the galaxy, there is no simultaneous moment. Each star exists in its own bubble of time, sending out messages that will not be received for years, decades, or centuries. Consider the sheer scale of a single light year once more. To visualize 9.5 trillion kilometers, imagine the distance from the Earth to the Sun, that 8-minute journey we discussed earlier. Now, take that distance and stack it end to end 63,000 times. That is 1 light year. It is a distance so long that if you were to represent the Earth-Sun distance as 1 inch, a single light year would still be over a mile long. And remember, the nearest star is over 4 of those miles away. This is the scale expansion that begins to blow the human mind. We aren't just moving away from home, we are moving into a geography that refuses to be tamed by our standard maps. What makes this strange is not what we see, but what we don't understand about the nature of the vacuum itself. Astronomers didn't expect to find that space is expanding, a discovery that adds a layer of quiet complexity to our journey. As light travels its 9.5 trillion kilometers every year, the space it is traveling through is itself stretching, very slightly, every second. It's as if the marathon track is growing longer while the runner is mid-stride. This doesn't affect our local neighborhood much, but over the immense periods of time that light spends in transit, it changes the very color and energy of the light itself. It is a slow, rhythmic stretching of reality that happens without hurry and without end. As you listen, let the rhythm of these numbers settle into your breathing. Ow, 300,000 kilometers per second. 18 million kilometers per minute. 1 billion kilometers per hour. These are not numbers to be feared or solved. They are simply the heartbeat of the vacuum. They represent the tireless work of the universe, moving energy from one place to another across the dark. You are safe in the knowledge that this process is constant. The speed of light does not falter. It does not tire. It is the one thing in the universe that remains exactly the same, no matter where you are or how fast you are moving. And for now, that uncertainty about why the universe is so large and why we are separated by such vast gulfs of time is simply part of the picture. It doesn't need to be resolved tonight. We can accept the silence of the light years. We can accept that the stars we see tonight are ghosts of their past selves, and that our own light is currently traveling outward, a faint signal crossing the void to reach eyes that won't exist for another million years. This is the cosmic continuity, the realization that we are all part of a single, slow-moving story. Imagine you are a photon that has just finished its first year of travel. You have covered 1 light year. You look back, and the sun is no longer a blinding disk. It has shrunk to a bright, steady point of light, one star among many. You look forward, and the destination still looks impossibly far away. There is no wind in space, no sound, and no resistance. You are simply falling through the dark at the maximum possible speed, a tiny spark of information in a cathedral of shadow. This is the essence of the scale loop. We expand our view, we realize the vastness, we accept the mystery, and then we move outward once more. To understand that, we need to step back and look at the human scale perspective one last time before it disappears completely. On Earth, we think of a year as a long time. It is a cycle of seasons, a series of memories. But to the universe, a year is just the time it takes for light to cross a tiny fraction of a galaxy. When we combine the two, the human year and the cosmic speed, we get the light year. It is our way of speaking the universe's language using our own alphabet. It is a gentle humility, acknowledging that while we may be small, we have found a way to measure the infinite. As we conclude this first scale loop, let the image of the light marathon carry you toward a deeper state of relaxation. The light is moving, but you are still. The universe is vast, but you are warm and safe. The distances are mind-blowing, but they are also orderly and predictable. There is a peace in the precision of the speed of light. It is the ultimate clock, ticking away the seconds across the trillions of kilometers. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We have reached the first marker on our journey. We have looked at the speed, we have looked at the distance, and we have accepted the delay. We are now ready to leave the inner solar system behind for good and look at the objects that wait for us in the deep, quiet dark of the interstellar gaps. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond the speed of light lies our own neighborhood, the solar system. To truly grasp the weight of a light year, we must first look at the smaller, more intimate delays that happen right here in our own backyard. We often think of our solar system as a single, cohesive unit, a family of planets huddling around a central fire. But even within this family, the distances are so great that light, the fastest messenger in existence, begins to show the first signs of its struggle against the void. This is where we first encounter the lag of reality, a gentle reminder that nothing in the universe happens in a true, synchronized now. What we know so far suggests that the Moon is about 384,000 kilometers away. To our human-scale perspective, this is a massive distance, a journey that took the Apollo astronauts 3 days of intense travel to complete. But for light, this gap is merely a brief pause. When you look up at the Moon tonight, you are seeing it as it was 1.3 seconds ago. It takes that long for the sunlight bouncing off the lunar surface to reach your eyes. This is the lunar delay. It is a small, almost imperceptible gap, but it is the first crack in the illusion of an instantaneous universe. If a large boulder were to roll across the lunar plains, or if a meteorite were to strike the surface, you would remain unaware of it for over a second. You are always watching a slightly delayed broadcast of our nearest neighbor. As we move past the Moon, the seconds begin to turn into minutes. The Sun, the very engine of our lives, sits much further away, about 150 million kilometers. This is the distance astronomers call an astronomical unit, or 1 AU. It is the gold standard for measuring our local neighborhood. Yet, even light needs time to cross this threshold. It takes 8 minutes and 20 seconds for a photon to travel from the surface of the Sun to the Earth. If the Sun were to suddenly go out, we wouldn't know it for 8 minutes. We would continue to live in its warmth and light, unaware that its source was already gone. Children would keep playing in the park, solar panels would continue to generate power, and the world would remain bright, all while the Sun itself was already dark. We would continue to orbit a ghost of a star for those final 8 minutes. This comparison isn't perfect, but it gives us a calm place to begin. It shows us that even the most fundamental things in our lives, the very light of day, are subject to the patient laws of cosmic distance. Scientists understand these delays by observing the movement of the planets. When we send rovers to Mars, for instance, we cannot drive them in real time with a joystick. Depending on where Mars and Earth are in their orbits, the light delay can be anywhere from 3 to 22 minutes. If a rover is heading toward a cliff, the signal telling it to stop takes minutes to arrive, and the confirmation that it has stopped takes another few minutes to return. We are forced to communicate with the solar system through a veil of time. We are always talking to the past version of the planets, and they are always responding to a past version of us. But even with everything we've learned, there are still things we don't fully understand about how these distances affect our perception. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. To understand the scale, imagine you are standing in a vast, dark forest. You have a friend standing a few hundred yards away with a bell. When they ring the bell, you hear the sound a moment later because sound travels slowly. In the solar system, light is like that bell. It is incredibly fast, but the forest is so big that the sound of the light still takes time to reach your ears. As we drift further out to the gas giants like Jupiter and Saturn, the minutes turn into hours. When we look at Jupiter, we are seeing it as it was 40 minutes ago. When we look at Saturn, the light has been traveling for over an hour. If you were to watch the beautiful rings of Saturn through a telescope, you are seeing them not as they are in this moment, but as they were while you were perhaps finishing your dinner or starting this very script. The universe is a series of nested time capsules, each one holding a slightly older version of reality. This brings us to a quiet realization. We are never truly in the present when we look at the sky. We are observers of history. The light minutes that separate us from the planets are the first steps toward the light years that separate us from the stars. It is a gradual expansion of the now until it becomes so thin that it disappears entirely. In our daily lives, we measure time in seconds, minutes, and hours. But in the solar system, we begin to see that time and distance are the same thing. 1 AU is not just 150 million kilometers, it is also 8 light minutes. The distance is the time. Astronomers didn't expect the solar system to feel so empty, yet the gaps between the planets are far larger than the planets themselves. If you were to shrink the sun to the size of a grapefruit, the Earth would be a tiny grain of sand about 50 feet away. Jupiter would be a cherry about 2 blocks away, and the nearest star, that grapefruit, would be thousands of miles away. This is why we need the light year. Kilometers are too small to bridge the gaps between the fruits in our cosmic orchard. When we think about distance, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. It is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the Moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, a beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit, and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the sun safely, through a filter, or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the sun, traveling through the cold dark for 8 minutes, and finally reaching the earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human scale perspective, we are also speaking of human scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts, the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car. But light is the ultimate speed. It is the speed limit of reality. Nothing can go faster. And yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. The roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. While you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human-scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were 1 billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3 second gap that you could never bridge. One level beyond what we just explored lies our own solar system. To understand the largest thing in the universe, we must first look at the largest thing in our immediate neighborhood, the Sunday. The Sun is so large that 1 million Earths could fit inside it. If the Earth were the size of a grain of salt, the Sun would be the size of a large beach ball. Scientists understand the Sun by observing its gravitational pull. which holds everything from Mercury to the icy reaches of the Oort cloud in a steady, rhythmic dance. What we know so far suggests that the Sun is the anchor of our existence. But even with everything we've learned, there are still things we don't fully understand. There are stars in the galaxy that make our Sun look like a pebble. Stars like UY Scuti are so massive that if placed at the center of our solar system, their surface would extend past the orbit of Jupiter. The scale is already becoming difficult to visualize, but because the universe moves slowly, over immense spans of time, these giants exist in a state of quiet equilibrium. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more, to an even larger scale. Imagine standing in a vast, open desert at high noon. You feel the heat on your skin, a steady, pulsing warmth that has traveled 93 million miles just to reach you. That light took 8 minutes and 20 seconds to arrive, crossing a vacuum of absolute cold to provide the energy for every breath you take and every dream you've ever had. In our daily lives, we treat the Sun as a constant, a reliable, yellow circle that marks the passing of our days. But if we were to peel back the layers of our atmosphere and look at it through the eyes of a scientist, we would see a churning, boiling sphere of plasma, a nuclear furnace so massive that it accounts for 99.8% of the total mass of our entire solar system. Everything else, Jupiter, Saturn, the Earth, the asteroids, and the lonely comets, is just the leftover dust from the Sun's creation. To truly grasp the Sun's size, we have to move beyond the beach ball analogy. Imagine a hollow sphere the size of the sundae. If you were to pour Earths into it, like marbles into a jar, you would have to pour for a long time. You would see them pile up at the bottom, thousands upon thousands, then hundreds of thousands, until finally, at 1,300,000 Earths, the jar would be full. This is the scale of the object that governs our lives. It is a gravity well so deep that it bends the very fabric of space, forcing the planets to roll around it like balls on a curved trampoline. It is the anchor, the weight, that keeps us from drifting off into the lightless void of interstellar space. And yet, in the grand inventory of the cosmos, astronomers classify our Sun as a yellow dwarf. It is a humble term, a reminder that in the neighborhood of the Milky Way, our giant is actually quite modest. If we were to leave the Sun behind and travel toward the constellation of Scutum, we would find UY Scuti. To call it a star feels like an understatement. It is a hypergiant. If the Sun were the size of a small cherry, UY Scuti would be the height of the Empire State Building. If you were to fly a commercial jet around its circumference, the journey would take you over 1,000 years. Generations of pilots would be born, live, and retire on that plane before it completed a single lap. This brings us to a strange realization. Size in the universe is often a matter of perspective. These hypergiants are not solid like the Earth. They are diffuse, like glowing clouds of hot gas, stretched so thin that their outer layers are barely more than a vacuum. They are puffy stars, swollen by the intense radiation of their own internal fires. Scientists understand these giants by measuring their luminosity, the total amount of energy they pour into space. A star like UY Scuti is hundreds of thousands of times brighter than our Sunday. If it were our Sun, the Earth would be vaporized in an instant. Even the distant, frozen reaches of Pluto would be hotter than a kiln. As we sit with this thought, we might wonder why such things exist. Why does the universe allow for objects of such staggering, unnecessary scale? There is no urgent answer. These stars are simply the result of gravity acting on vast clouds of hydrogen over millions of years. They burn through their fuel with a frantic intensity, living fast and dying young in brilliant supernova explosions. Our Sun, being smaller and more conservative, will live for 10 billion years. The hypergiants might only last for a few million. There is a trade-off in the cosmos. To be that large is to be fleeting. To be smaller is to endure. Beyond these individual stars, we begin to see the empty spaces that define their existence. Between our Sun and the next closest star, Proxima Centauri, lies a gap of 4 light-years. That is 24 trillion miles of nothing. If you were to represent the Sun as a grain of sand in London, the next grain of sand would be in Paris. The object we call the solar system is mostly this: the silence and the distance between the grains. This is why it is so difficult to visualize the largest structures. We are used to things being crowded together, but the universe is a place of immense, lonely roominess. When we look at the Oort cloud, the outermost shell of our solar system, we are looking at a collection of icy rocks that are so far away they barely feel the sun's warmth. They move at a glacial pace, taking tens of thousands of years to complete a single orbit. At this distance, the sun is just a very bright star, no longer a dominant disk in the sky. Yet the sun's invisible fingers of gravity still reach out and hold these icy wanderers in place. This sphere of influence, the heliosphere, is our first true, large object. It is a bubble in space, carved out by the solar wind, protecting us from the harsher radiation of the galaxy beyond. What makes this strange is not what we see, but what we don't understand about the boundaries. We have sent Voyagers 1 and 2 to the edge of this bubble, and they have felt the change in the wind. They have crossed the threshold into the interstellar medium, the sea between the stars. It is a transition that happens without a sound, a slow drift from one realm to another. Astronomers didn't expect the boundary to be as complex as it is. They found magnetic bubbles and unexpected fluctuations in the cosmic rays. But even these surprises are delivered to us in a flat, predictable way. The data trickles back across the billions of miles, and we analyze it over decades. There is no rush to find the answer. The Voyagers will continue to drift for tens of thousands of years before they even come close to another star system. They are the quiet messengers of our scale, tiny specks of metal in a sea of plasma and light. As we dwell on the Sun and its family of planets, we begin to see the pattern that will repeat as we move outward. Everything is a part of something larger. The Sun is a member of a stellar cluster. The cluster is a member of a galactic arm. The arm is part of the galaxy. The largest object is not just a single thing, but a nested series of influences. Just as a single drop of water is part of a wave, and the wave is part of the tide, the Sun is a single pulse in the vast, rhythmic life of the Milky Way. The uncertainty of these scales is simply part of the picture. We don't know exactly how many hypergiants are hiding in the dust clouds of our galaxy. We don't know the precise shape of the Oort cloud. And that is perfectly fine. The universe moves slowly, and we have all the time we need to watch it unfold. The stars we see tonight are the same stars that were seen by the first humans, and they will be the same stars seen by those who come long after us. They are the silent witnesses to our history, existing in a state of quiet equilibrium that we can only hope to emulate. With that in mind, let's move outward once more. Let us leave the warmth of the sun behind and travel toward the center of the galaxy. We are moving away from the light and toward the dark, toward an object that is not defined by its surface, but by its depth. We are moving toward the gravity that holds 100 billion suns in a single, swirling embrace. To understand the largest things in existence, we must first look at the anchor of our own existence, the Sunday. It is the dominant presence in our lives, a massive, glowing sphere that provides the energy for every heartbeat on Earth. But in the context of the universe, the sun is merely a starting point, a standard candle by which we measure the truly gargantuan. If you were to hollow out the sun, you could fit 1.3 million Earths inside it. Imagine that volume. If the Earth were the size of a single grain of salt, the sun would be a large beach ball, and the distance between them would be nearly 100 yards of empty space. This is the scale of our immediate neighborhood, a place where gravity is the invisible hand that keeps everything in its proper place. As we move outward, we see that the sun is part of a larger family, the solar system, which stretches out to the icy reaches of the Oort cloud. This cloud is a vast, spherical shell of frozen objects, some the size of mountains, orbiting so far away that the sun is just a very bright star in their sky. Scientists understand this structure by observing the long-period comets that occasionally visit the inner solar system, falling toward the sun like icy tears from the edge of the void. What we know so far suggests that the sun's gravitational influence extends for nearly 2 light-years, a distance of 12 trillion miles. But even this immense bubble is small compared to the stars that reside further out in the galaxy. We call our sun a yellow dwarf, a term that feels humble when compared to the hypergiants. Consider UY Scuti, a star so large that if it replaced our sun, its surface would extend past the orbit of Jupiter, engulfing all the inner planets in a silent, incandescent glow. If you were to fly a commercial airplane around the circumference of UY Scuti, the journey would take you over 1,000 years. You would spend 10 centuries in the air just to complete one lap around a single star. What makes this strange is not just the size, but the density. These hypergiants are not solid, they are diffuse and puffy, held together by a delicate balance of radiation and gravity. They are like massive, glowing clouds of plasma, burning through their fuel with a frantic intensity. Astronomers didn't expect to find stars of this magnitude when they first began mapping the sky. But the universe moves slowly, over immense spans of time, allowing these giants to exist in a state of quiet equilibrium. They are the elders of the stellar community, beacons of light that can be seen from thousands of light years away. As we drift further from these individual giants, we begin to see the space between them. In our daily lives, we are used to things being close together, houses on a street, cars in a lane. But in the cosmos, distance is the defining characteristic. Between our sun and the next closest star, Proxima Centauri, lies a gap of 4 light years. To bridge that gap at the speed of a human walking would take nearly 1 billion years. The object we call the solar system is essentially a tiny island in a vast, dark ocean. The largest object we are searching for is not just a single thing, but a collection of these islands, arranged in a way that suggests a grand, underlying order. Scientists understand these stellar neighborhoods by measuring the parallax of stars, the tiny shift in their position as the Earth moves around the Sunday. It is a slow, meticulous process, requiring years of observation to map even the closest stars. What they find is that the galaxy is not just a random collection of suns, but a structured system with spiral arms and a dense, glowing core. Our Sun is located on the inner edge of the Orion Arm, about 26,000 light-years from the center. We are in the quiet suburbs of the Milky Way, far from the crowded, energetic heart of the galaxy. This brings us to a sense of perspective. If our entire solar system, out to the furthest reaches of the Oort cloud, were the size of a single penny, the Milky Way galaxy would be the size of the entire United States. We are a small, quiet part of a much larger whole. The gravity that holds us in orbit around the Sun is the same gravity that holds the Sun in orbit around the galactic center. It is a nested series of influences, a hierarchy of scale that begins with a grain of sand and ends with the cosmic web. But even the galaxy is not the end of the story. As we move outward, we see that the Milky Way is just one of many galaxies in our local group. To understand the largest object we've ever found, we must look beyond the individual stars and the spiral arms. We must look at the way galaxies themselves are grouped together. This challenges how we think about objects. Is a group of galaxies an object? Or is it a neighborhood? In the deep cosmos, the distinction blurs. A structure is defined by the way its parts move together, guided by the invisible hand of gravity and the presence of dark matter. What makes this strange is the sheer emptiness of it all. If you were to take all the stars in the Milky Way and crush them into a single solid mass, they would occupy only a tiny fraction of the galaxy's volume. The rest is space cold, silent, and nearly empty. Yet, this emptiness is not truly empty. It is filled with magnetic fields, cosmic rays, and the mysterious dark matter that provides the scaffolding for everything we see. Astronomers didn't expect the universe to be so dominated by the invisible. But the more they look, the more they find that what we see is only a small part of the picture. And for now, that uncertainty is simply part of the picture. We don't need to know the exact nature of dark matter to appreciate the scale of the structures it creates. We can simply watch the stars in their long, slow migration through the dark, knowing that we are part of a system that spans billions of light years. There is no urgency to find the final answer. The universe moves at its own pace, and we are simply observers, drifting along for the ride. As you settle into the silence of the deep cosmos, let the scale of the Sun and its neighbors act as a soft weight, grounding your thoughts. You are safely anchored in your own little corner of space, protected by the Sun's magnetic breath and held in place by the Earth's steady gravity. The vastness of the universe is not a threat, it is a context. It is the backdrop against which your life unfolds, providing a sense of scale that makes everything feel manageable and calm. We are moving away from the light of the Sun now, heading toward the dark heart of the galaxy. We are leaving the familiar behind and stepping into the realm of the supermassive. The journey is long, but it is also quiet. There is no noise in the vacuum of space, only the steady pulse of gravity and the slow expansion of the void. You are a passenger on a journey that has no end, moving through a universe that is both unimaginably large and beautifully simple. With that in mind, let's move outward once more to the galactic center, where the density of stars reaches its peak and the gravity of a supermassive black hole defines the motion of an entire galaxy. We are heading toward an object that is not defined by its surface, but by its influence, a place where time and space are warped in ways that defy our everyday experience.